Hello students, now today we will discuss periodic versus aperiodic signals. So in the previous lecture already I told you what is energy signal and power signal, how to judge whether the discrete signal is energy or power. So again if I told you the energy E of a discrete signal x of n can be defined as, that is your E equal to minus n equal to minus infinite to infinite x of n square. Then how to calculate the average power? The average power of a discrete signal x of n can be defined as, that is your limit n tends to infinite 1 by 2n plus 1, where n varies from minus n to n x of n square. If x of n is given, how to examine whether the particular discrete signal is that is your energy or power. If energy is finite, you can say that it is an energy signal. If power is finite, you can say the power signal. If energy is infinite, then you will check whether the power is finite or not. If the power is finite, then we can say that power signal. If energy is infinite and power is infinite, the signal is called neither energy nor power signal. Now today we are going to discuss that is your periodic and aperiodic signals. You might have studied what is periodic signal, as you have studied in your plus 2. What do you mean by periodic signals? The periodic signals, now we are going to discuss about the discrete signals x of n. The discrete signal x of n is periodic. The discrete signal, the discrete time signal, the discrete time signal, the discrete time signal x of n, the discrete time signal x of n the discrete time signal x of n is said to be periodic, is said to be periodic, is said to be periodic is the condition. The discrete time signal x of n is said to be periodic, then x of n must be equal to x of n plus capital N for all values of n, for all values of n. So discrete time signal x of n is said to be periodic, then x of n equal to x of n plus n. What is n? Capital N. N is nothing but your fundamental period. The fundamental period. How to judge whether the discrete signal is periodic or not? If this condition is not satisfied, we can't say that the signal is a aperiodic signals. If this condition is satisfied, then the discrete signal x of n, we can say it is an periodic signals. Otherwise, we will say it is nothing but aperiodic signals. For example, if I will say, suppose the sequence is like this, for n equal to 0, like this, for n equal to 0, n equal to 0, this is your 1, x of n is 1, n equal to 1, that is your 2, n equal to 2, this is your let 3, and n equal to, this is your 2, n equal to 3, that is your what? That is your 4, this is your 4. But we can say that the sequence, this is your n, and this is your x of n. Again 4, this is your 1, again 2, and this is your 3, and this is your 4. So this is nothing but 4, 5, 7 like this. Similarly also like this. What will you observe? So here every 4 samples the sequence is repeated. For every 4 samples the sequence is repeated. We can say that it is a periodic signal. The discrete signal x of n is said to be periodic if and only if x of n equal to x of n plus n. In this example, so every n equal to what? How will judge n? N equal to what? N is nothing but what? N equal to 4. So every 4 samples the sequence is repeated. Here also similarly, like this is 1, this is 2, and this is your 3, and this is your 4. So every 4 samples at n equal to 4, so this sequence is repeated after n equal to 4. That's why you can say that the signal x of n is a periodic signal. If any one of the samples deviates, we can say that the sequence is nothing but what? Aperiodic signals. So the signal is periodic if and only if it will satisfy the condition x of n equal to x of n plus capital N, where n is your fundamental period. For example, a continuous time signal, if we will say a continuous time signal, suppose a sinusoidal signal, x of t equal to your a sin omega t, a sin, this is your omega t, omega 0 t. Any continuous time signal, this is your discrete n, and here we can write that your t for continuous. So we can say that a continuous time signal, a sinusoidal signal is a periodic signal with a period what? Period of 2 pi. The signal, the continuous time signal or sinusoidal signal is periodic with the period 2 pi. If we will say for a continuous time signal, we can say that is a periodic, the condition is what? X of t equal to, that is your x of t plus what? Capital T. Here t is your fundamental period. Here t is your what? T is nothing but fundamental period. Fundamental period. T is nothing but fundamental period. That means, suppose here this is a sinusoidal signal, this is your sinusoidal signal, continuous time signal. This is your 0, this is your pi, and this is your 2 pi, this is your 3 pi, and this is your 4 pi, like this. So if you will observe here, if this is your t, x-axis is your t, and y-axis is nothing but what? That is your x of t. We can say that any here the period, we can say that t equal to 2 pi. So here this is repeated like this. We can say that here t is your fundamental period. So the continuous time signal is said to be periodic. A sinusoidal signal is said to be periodic with the period 2 pi. We can say that t is your fundamental period, here t equal to 2 pi. For example, I will say if x of t equal to a sin omega 0 t, then x of t plus t is how much? X of t plus capital T is how much? That is your, in place of t we can place t plus capital T. So that's why a sin that is your omega naught, in place of t you will put what? T plus capital T. So that's why it can be written as, where here a is the amplitude, omega is the frequency. A is the amplitude and omega is your frequency. So it can be written as, that is your a sin omega 0 t plus omega 0 capital T. Okay, suppose let this is your equation 1 and this is your equation 2. We can say that a continuous time signal or sinusoidal signal is periodic with the period 2 pi. Here if you look this equation equal to this equation 1 equal to equation 2. If this equal to this, means what? Omega 0 t value is how much? Omega 0 t value is nothing but 2 pi. So omega 0, the value of omega 0 equal to 2 pi. Or omega 0, omega equal to 2 pi f, f equal to 1 by t, f is the frequency, t is the time period. So in if you express omega in terms of time period, the omega value is nothing but what? That is your 2 pi by capital T, 2 pi by capital T. Here we can say that omega 0 and omega 0 capital T here. And this omega 0 t, omega 0 capital T equal to 2 pi, omega 0 capital T equal to 2 pi. And the t value is how much? 2 pi by omega 0. T equal to 2 pi by omega naught. Okay. So if a sum of sinusoidal signal is given, suppose this is a single sinusoidal signal is given, so we have to examine whether the signal is periodic or not by means of what? That is your, in terms of calculate the every sinusoidal signal is periodic with the period 2 pi. Suppose a multitone signal is given. Multitone means what? More than one sinusoidal signals. If more than one sinusoidal signal is given, how will you judge whether the signal is periodic or not? For example, that is your, I have given some of the examples. So examine the following signals are periodic or not. If periodic, find the common period. These are the few examples given. This type of examination, this type of question may come in your civil service examinations, or some you will find and some competitive examinations. The signal is given, you have to judge whether the signal is periodic or not. And this is a multi-tone signal. Multi-tone means what? More than one sinusoidal signals. So this is your first example. X of t equal 3 cos t by 2 plus 5 sin t by 3. That is your in first example. Solution. So x of t here, x of t equal to x of t equal to 3 cos t by 2 plus 5 sin t by 3. This is your sum of sinusoidal signals given. This is nothing but we can say this is your let x1 of t plus, and this we can say that is your x2 of t. Okay. X of t equal here x1 of t plus x2 of t. x1 of t is how much? x1 of t equal to that is your 3 cos t by 2. To calculate or to examine whether the signal is periodic or not, we should least bother about the amplitude. We have to find out the fundamental period, means frequency. Cos omega t, here omega, that is your what? 3 cos t by 2. Here omega value is omega t. We can say it is nothing but that is your cos omega t, means omega 1 t. Here omega 1 value is how much? Here suppose amplitude A, omega 1 value is nothing but what? Coefficient of t is nothing but 1 by 2. So omega 1 or frequency equal to that is your 1 by 2. Omega equal to 2 pi f. Omega is the frequency. So 2 pi f and omega 1 is nothing but 2 pi by t1. 2 pi by t1. So 2 pi f, value of omega equal to 2 pi f. F is the frequency. So f equal to 1 by t. So time is nothing but reciprocal of the time period is nothing but reciprocal of frequency, and frequency is nothing but reciprocal of time period. If time period is given, that is 1 by t equal to f to calculate the frequency. If frequency is given, 1 by f equal to t. And here cos omega t, omega 1 value is 1 by 2. So 2 pi by t1 equal to 2 pi by t1 equal to that is your 1 by 2. And t1 value which implies t1 is how much? t1 equal to 4 pi. In first sinusoidal signal, t1 equal to 4 pi. Similarly, second one, that is your x2 of t. x2 of t is how much? x2 of t equal to your what? 5 sin t by 3. 5 sin t by 3. So we can say this is nothing but let a sin omega 2t say. Okay. Now our intention is to calculate the time period. This is your, in first sinusoidal signal we can calculate the time period t1. In second sinusoidal signal we have to calculate the t2. t2 is your fundamental period. So that means here omega 2 value is how much? Omega 2 value is 1 by 3 here. And here from this example, omega 2 is nothing but coefficient of t is your omega 2, here coefficient of t is your 1 by 3. So that's why omega 2 is nothing but what? 1 by 3. And the value of omega is how much? 2 pi by t. And here second periodic signal, second continuous signal. So we can naming here 2 pi by t2. 2 pi by t2 equal to 1 by 3. Which implies t2 is how much? t2 equal to that is your 6 pi. In first periodic signal or first continuous signal, we have calculated t1 equal to 4 pi, and second signal, that is second sinusoidal signal, t2 equal to 6 pi. And here fundamental period of this is nothing but 4 pi. Here fundamental period of this second is nothing but 6 pi. One important thing is, it is very very important, if the sum of multi-tone signal is given, you have been find out how to calculate the common period t and how to judge whether the signal is periodic or not. These are the following formula. It is very key important thing is what? First of all, you have to calculate t1, first calculate t1 and second calculate t2. If another signal is given, calculate also t3. This is t1 is nothing but fundamental period of the first sinusoidal signal, and T2 is nothing but fundamental period of the second sinusoidal signals. Then in second step, this is your first step. In second step, what? That is your T1 by T2. Calculate T1 by T2. If T1 by T2 is a rational number, if T1 by T2 is a rational number, means P by Q where Q not equal to 0. If T1 by T2 is a rational, if T1 by T2 is a rational, means rational number, we can say that the signal is periodic. Again, if the multitone signal is given, first of all you have to calculate the fundamental period of respective signals. First is your x1 of t, this is your x2 of t. We can calculate the x1 of t, the fundamental period t1 equal to 4 pi. In second signal, we have calculated the t2 equal to 6 pi. Then we are going to calculate whether the signal is periodic or not. First of all, then calculate after getting t1 and t2, then evaluate whether t1 by t2 is a rational or not. If T1 by T2 is a rational number, we can say that the signal is periodic. If T1 by T2 is not rational, we can say that the signal is not periodic, it is an aperiodic signal. So here in this example, T1 by T2 is how much? T1 by T2. So T1 by T2 equal to, here T1 equal to 4 pi and T2 equal to your 6 pi. So pi cancel, that is your 4 by 6. 4 by 6 is nothing but 2 by 3 and it is a rational number. It is a rational number. So that the signal is a periodic signal. Therefore, since T1 by 2 is a rational, it is a periodic signal. Periodic signal. It is a periodic signal. Okay. Then find out the common period. One important thing is how to calculate the common period. We have examined, we have evaluated the signal is a periodic signal. Then next step, to calculate the common period. If the common period, if T1 you know and T2 you know, and the common period is what? LCM of T1 and T2. To find the common period, to find the common period, but LCM of but first T1 4 pi and 6 pi, 4 6 LCM, but this is nothing but, and you calculate 4 6 LCM, that is your 12. So that is nothing but 12 pi. Therefore, the common period of this multitone signal is your nothing but your what? That is your 12 pi. It is most of the important thing. Whether the multitone signal is given, you are going to calculate whether the signal is periodic or not. In this process, you will calculate individually. First of all, calculate the fundamental period. Let this one x1 of t and x2 of t, t1, t2 you calculate. After getting t1 and t2, then find out t1 by t2 is a rational or not. Then t1 by t2 is a rational number. If t1 by t2 is a rational number, we will say that it is a periodic signal. After you know the signal is periodic, now find the common period, and LCM of t1 and t2, it is nothing but 12 pi, and this is what we can say that it is the periodic signal, and common period is your 12 pi. And second example, let us do the second example. In second example, x of t equal to a cos t into root over of t root 2 plus b sin t by 4. In the second example, in second one, x of t equal to your x of t equal to a cos t into root 2, a cos t into root 2, a cos t into root 2 plus b sin t by 4, b sin t by 4. Same procedure here, and x1 of t here, what? x1 of t equal to your t into root 2. We will and we are going to calculate the fundamental frequency or fundamental period. That is nothing but what? X1 of t equal to your x1 of t equal to a cos t into root 2, and which equal to say that is your a cos omega 1 t, say, okay, omega 1 value is how much? Omega 1 equal to, that is your root 2, and omega 1 value is what? 2 pi f, 2 pi by t1, 2 pi by t1, 2 pi by t1 is nothing but root 2, and which implies t1 equal to 2 pi by root 2, 2 pi by root 2. And clear, you say root 2 is an irrational number. Since root 2 is an irrational number, it is not a periodic signal. So next step, you may not proceed. You confirm that since that is an root 2 is an image, that is your irrational number is given, since root 2 is an irrational number, since root 2 is an irrational number, the signal is a periodic signal. Signal is a periodic signal. A periodic signals. One, you know the signal is aperiodic. There is nothing to calculate the fundamental common period of the multi-tone signals. So since the root 2 is an irrational number, we can say that it is an aperiodic signals. Another example is what? Number 3. In number 3, that is your a sin t cube. A sin t cube. X of t equal to a sin t cube. Okay. So how will you calculate this one? As you know that this is nothing but a cube sin cube t, and this is nothing but what? We can say that is your a cube sin cube t, and here we can say this is an amplitude and this is your sin cube t. So you have to split sin cube t. As you know that that is your sin 3a. What is your formula sin 3a? That is your 3 sin a minus 4 sin cube a. Okay, and this is your sin 3t. That is your, we can say that here sin 3t. Suppose if I will say t, sin 3t equal to t sin t minus 4 sin cube t. So you have to express sin cube in terms of this one, so that we can calculate the fundamental period of t1 and t2. Here we can say that 4 sin cube t, that means what? That is your sin 3t. This is nothing but what? Four sin cube t, you will be bringing the left side, and it is nothing but 3 sin t minus sin 3t, and sin cube t equal to that is your 1 by 4, means 3 by 4, 1 by 4 all into 3 sin t minus sin 3t, and this is nothing but what? And in place of this, so you can write that is your a cube, in place of sin cube t, you can write what? A cube into 1 by 4 all into that is your 3 sin t minus sin 3t. Okay, and we can say that is your a cube by 4 into like this. Our intention is what? Omega 1 value is what? 1 here, 3 sin omega t, and omega 2 value is what? 3. And here x1 of t, we can say that x1 of t equal to your sin t. Sin t means what? Sin omega 1 or omega 1 equal to, that is your 1, or omega 1 value is nothing but what? 2 pi by t1. 2 pi by t1 equal to 1, or t1 value is how much? t1 equal to 2 pi. Here t1 equal to 2 pi. Similarly, omega 2 value is what? Second signal. Omega 2, sin omega t, omega 2 equal to 3. Omega 2 is nothing but 2 pi by t2. So 2 pi by t2 equal to 3. Or t2 equal how much? t2 equal to, or t2 equal to, that is your 2 by 3 pi. So t1 equal to 2 pi, t2 equal to 2 by 3 pi. Okay. So then calculate t1 by t2, whether the signal is periodic or not. If t1 by t2 is a rational number, we can say that the signal is periodic signals. So t1 equal to how much here? So t1 by t2. Then calculate t1 by t2. t1 by t2 is your what? t1 equal to 2 pi. This is your 2 pi divided by 2 pi by 3. 2 pi divided by 2 pi by 3. And which equal to 2 pi into 3 by 2 pi. So that is your 3. And 3 is nothing but 3 by 1. And it is a rational number. So since t1 by t2 is a rational number, the signal is periodic signals. So 3 is nothing but, we have to check whether the t1 by t2 is a rational number or not. Since t1 by t2 is a rational number, we can say that the signal is periodic signals. Okay. So then another example. This is your what? X of t equal to 2 sin 2 by 3t, 4 cos 1 by 2t plus 5 cos 1 by 3t minus 1. Here t1 is how much? Omega 1t. Omega 1 equal to 2 by 3. So omega 1 equal to 2 by 3. Omega 2 equal to 1 by 2. Omega 3 equal to nothing but 1 by 3. In this way, you can find out t1, here also t2 and t3. Check t1 by t2 is a rational or not. Check t2 by t3 is rational or not. If t1 by t2 is rational and t2 by t3 is rational, we can say that the signal is periodic. And if you want to calculate the common period, LCM of t1, t2, t3, and whatever the value, this is nothing but your common period of the continuous time signal x of t. Okay, so let us do in the fourth example. So in this example, first of all, we will calculate, that is your x1 of t equal what? In number 4, question number 4 here, x1 of t equal what? x1 of t equal to your sin 2 by 3t. Okay, omega 1 equal to 2 by 3, or omega 1 is nothing but 2 pi by t1. 2 pi by t1 equal to 2 by 3, or t1 equal to, or t1 equal to 6 pi by, here 2 to cancel, so t1 equal to 3 pi. t1 equal to 3 pi. t1 equal to 3 pi. Okay. Similarly, x2 of t equal to what? Cos 4 cos 1 by 2t, and here omega 2 is how much? Omega 2 equal to 1 by 2. Omega 2 is nothing but 2 pi by t2 equal to 1 by 2, or t2 equal to 4 pi. This is your t2, fundamental period of the second period, continuous signals. Then this is your first one, and this is your second one, and another one, x3 of t equal to how much? x3 of t equal to your what? 5 cos, that is your 1 by 3 t minus 1. This is your cos omega t minus phase shift theta, and this is your phase shift. Here omega 3 value is how much? Omega 3 equal to cos omega 3 t 1 by 3, omega 3 equal to 1 by 3, or 2 pi by t3 equal to your 1 by 3, or t3 equal to 6 pi, or t3 equal to 6 pi. Okay. For these continuous time signals, multitone signals, we have calculated T1, T2 and T3. Here T1, first signals T1 equal to 3 pi, second signal T2 equal to 4 pi, and third one is your T3 equal to your 6 pi. Then we will check whether T1 by T2 or T2 by T3 is rational or not. So then we will calculate whether the signal is periodic or not by T1 by T2 and T2 by T3, because there are 3 sinusoidal signals. The sum of 3 sinusoidal signals are given. We have to calculate T1 by T2 and T2 by T3. So check T1 by T2. T1 by T2 is how much? So here T1 equal to 3 pi, T2 equal to 4 pi. So 3 pi by 4 pi. 3 pi by 4 pi, and it is nothing but 3 by 4. Similarly, T2 by T3. T2 by T3 is how much? So T2 by T3, 4 pi by 6 pi. 4 pi by 6 pi, and it is nothing but 4 by 6. So since T1 by T2 it is also rational number, and it is also rational number, the signal is a periodic signal. Since T1 by T2 and T2 by T3 are rationals, the signals, the multitone signal is a periodic signal. Then to find out the common period, then LCM of 3 fundamental period T1, T2 and T3. To find the common period, what? That is your LCM of T1, T2, T3, which equal to your LCM of T1 value is your 3 pi, another is your 4 pi, another is your what? 6 pi. So 3, 4, 6 LCM, that is your 3, 4, 6, and this it is nothing but what? Okay. 3 to the 6, 3 the 18 to the 36. So common period T equal to what? That is your 36 pi, and it is one common period of these multitone signals. So in this way you will calculate, or you have to judge whether the continuous signal is periodic or not. If periodic, then find the common period. If the multitone signal is given, individually find out the common period, fundamental periods, then find out the rationals T1 by T2. If 3 signals are given, 3 sinusoidal signals are given, then T1 by T2 and T2 by T3, and both are rationals, then we can say that it is an periodic signals. Otherwise you can say that it is not a periodic signal, or it is an aperiodic signal. If it is a periodic, find the common period and LCM of T1, T2 and T3, then you will calculate what is the common period. Similarly also in discrete time signals, also x of n is given. If x of n is given, how to calculate whether the signal is periodic or not. In next class we will do more and more number of problems about the discrete signal x of n, whether the signal is periodic or not, and if the periodic, find the common period. Thank you.